Alright, here we have another example that says 4 to the x minus 4 power equals 16. Well, if you remember again, the only thing we have to work with are all the rules and the properties that we've learned about exponentials and logs up to this point. Well, we had a rule that said if a to the u equals a to the v, then u has to equal v. If the bases of the exponential are identical, then the exponents must equal each other also. So looking at our problem, we actually could get those bases to be the same thing, because we could rewrite 16 as 4 squared. So this would now be 4 to the x minus 4 equals 4 squared. Our bases now are the same, so our exponents have to equal each other. X minus 4 has to equal 2. Now if I add 4 to both sides, then we get x equals 6. Now again, we should probably double check our answer. So if we were to plug in 6 in place of x, this would be 6 minus 4. Well, that would be 2, and 4 squared is in fact 16. So that does check, and x equals 6 is our correct answer. Let's try another one. Here we have 9 to the negative x equals 2.2. Well, this one's not as easy as the one we just completed, because I just do not know how to turn 9 into 2.2 to a power, or 2.2 to a power into 9. That's just unbelievable. But we're going to do a twist on this rule. Remember the rule that said if we've got log base a of m equals log base a of n, then m equals n, and vice versa. If we have two things equal to each other, then the logs of both of those should also be equal to each other. Aha! Watch this little trick. What I'm going to do is I'm actually going to take the log of both sides of this equation, and I'm going to use natural log. I prefer natural log when I'm working, so I'm going to take the natural log of 9 to the negative x equals the natural log of 2.2. Now, because we've introduced logs, all those log rules apply now. So our exponent here can be dropped down in front to make negative x, natural log of 9, equals natural log of 2.2. And now we can get x alone very easily by dividing both sides by negative natural log of 9. Because when we do that, our negative will cancel and the natural log of 9 will cancel, and we have x equals the natural log of 2.2 divided by negative natural log of 9. This is our exact answer. Now, if we were to plug this in on our calculator, then we would get a decimal approximation answer. Now, you should, if you watch your parentheses and everything, remember when you're entering this into the calculator, it will automatically put in a parenthesis after the natural log. So you have to balance that out at the end of the argument. Also, in the denominator, you'll have to do the same thing. You'll have once we hit natural log, it will automatically open a parenthesis, so you'll have to balance that out at the end of the argument. Now, if you enter that in correctly, you should get negative 0.359 as your answer.